Okay, this is my screencast for my week 1 and 2 Unity project. This is Gerald Quick for my emerging mobile technologies for Full Sail. So this is my project in Unity, and I currently have my wife logged in on another system, and she is waiting for me to come in now. So I will show this quick demo of the gameplay. I'm going to enter my username. Alright, let's see if I can find her. There she is. Oh my god. I can hear her laughing. Ah, I got her. So then I got my little game over screen. Okay, so now that you've seen the what the game, how the game runs, and that's using the Photon Unity plugin from Exit Games, and so I will go through the source code here. Now, the good thing I like about Unity is a lot of the assets or control scripts are already provided by default. I just had to make some minor modifications to suit my needs. So I will go over, when I go over the scripts, I'm just going to go over the changes that I've made. Okay, so let's see. Let's get started with the Photon Unity. So once you download the Unity, Photon Unity from the Asset Store, you import it into your project, and it'll add this to your extension, or it's an extension to your editor, excuse me. So if you click here, the wizard will pop up, and you have where you can set up your actual Unity cloud. Now, if you go to the website and sign up for an account, which is free, it gives you an app ID. So when you look in there, you put your app ID inside and then save it, and that's it. You're good to go as far as the Unity side connecting. Once you have your Photon set up with your app ID, you go, you're ready to connect your code. Now I have here some empty game objects that hold scripts. I could have put them all together as one, which would make more sense. However, I didn't, considering I have time frame. I was just trying different things out. But in my networking code here, let's zoom into it. Alright, so I have some variables that I created to hold like the player name, whether they join the lobby or the room, and I have a rectangle here set up for the window that I use for the username. Now, hold on, let me see if I can close this, or expand it. I'll close it in. There we go. Now I can, that's better. Alright, so let's start with the actual networking code here for connecting to Unity. So here I make a static instance of this script. So that way when another player comes in, they just pull the instance of it if it exists. If not, then it recreates it. I did this for when I was trying to implement spawning to make sure that it's using the same variables in the same script. So here, where it starts, this is where I actually connect. This is all that's needed for Photon Networking. If you just put Photon Network connect using, now it's based off of version numbers. So here I just put in 1.0. So if I created another client that was, let's say, version 1.2, and you put 1.2 in here, when they connect, they will not connect to the same room that's generated by your 1.0 clients, which is pretty cool. But this is the only function you have to call to actually connect to the Photon cloud. And then I have these events here that are called, as soon as you connect to the cloud, you join the lobby. So here I just set that the lobby is true, and I do this for just for my GUI. After this is true, I go up to my onGUI function here. So my onGUI function will display a label showing the connection state, whether you're connected, joined a lobby, or a room. And then if the joined lobby is true, then it'll go ahead and ask for the player name. So the way the GUI window works is you pass it the rectangle and a function to call whenever it's running, and then the title of the window. And then the actual function that's called every frame is here, and basically I just have a button, and if the user clicks on the button and if they don't enter a name, it creates a name of player with a random number from 0 to 20. And then you take the Photon network, I assign the player name to that network player, and this is anytime they call the Photon network.player name, that's relative to the local client. And then just do join random room. So once you do join random room, you have a couple callback functions here. I have on random room join failed. So then if it can't join a random room, if no rooms exist, it'll fail. So when it comes here, I go ahead and create a room with no name. It just doesn't matter. And then it'll the callback for the on join room is here, and then I spawn the player. And then in the spawn player function here, we have a rotation that holds, I just pick a random rotation to rotate the character pointing a certain direction. And then you take the player game object, and if you use the Photon network instantiate, it instantiates the object to all, throughout the network. So all the clients see it. Now, one thing to note is that if you're going to instantiate anything from Photon Network, it has to be in your resource. You have to make a folder called resources, and it has to be in that folder in order for it to call it. And then it's just the name of the game object. Okay, so then here I have a controller, a character controller that I grab. Once this is instantiated, I grab the character controller, and I set a variable on there is controllable to true. And I'll explain that a little bit more later. It's actually very important. And then I grab another one of my scripts that I have called player, just so I can get the name plate that I have, and I assign it the network name of the character. And then I grab the camera that's attached to that player, and I enable it. And then same thing for the third person camera script, and I enable that as well. And the reason why is, I know you're thinking, well, why don't you just have it enabled and just instantiate the game object? The problem is, if you do that, that script is shared throughout everyone on the network. So what will happen is, if you instantiate the object and all this is enabled, it'll be fighting over control for the camera, everything. So it just goes kind of crazy. So when you do it this way, you instantiate a character, and then you take and you start setting these variables here. This is just for the local client. So when I log in, this stuff is set and enabled, so I control it. and then whenever the network client, the network character is instantiated, this isn't controlled by me. So, and then I have a couple helper functions here that I started to do, but I didn't get around to finishing. I found a project that someone else did with spawn points for randomly spawning, and it worked pretty well. I still have some issues on mine for some reason, but anyway, I have a function that I can call from the spawn point class that I have that registers that spawn point inside the networking instance. And then the get spawn location will just check those spawn points and make sure that they're clear, there's no characters there, and then it'll assign it back up here to the player for check spawn location. However, it's not working 100% right now. Every once in a while, for some reason, it doesn't pick up the fact that nobody's there. And then these are not being used at the moment. The delayed player spawn and destroy and respawn, those are functions that I had created in hopes to have respawning, because right now you can't. The game's over, right? And then it goes back to the main menu. And that's it for the actual connecting to Photon networking and instantiating the character. Now if we look at my resources folder here, I have the player control. In order to instantiate a character, you have to have the Photon view component on it. And then you pick what it's observing, because this is what it serializes across the network. And what I have is there's a script that I have here called network character. So we'll look at this one here. So let me zoom in a little bit. So this one you'll notice it's a photon mono behavior. So it has all the normal mono behavior functions plus a couple other wrappers and stuff that Exit Games had did in here. So I have a couple variables, or a few. This vector here, it holds the correct player position and the correct player rotation. And then this is a projectile position and the projectile rotation. Now the reason it's done this way, this is how you smooth out the character movement, because if I didn't do it this way, the characters would jerk around the screen because it's moving them to their correct position, right? But then you got the lag of the network and everything. So what you do is you take and you lerp the current position that they're at to the correct position, over time. And I'm doing it over 2 seconds, and it seems to work okay, but it's better than being jerky. Now on Photon serialized view here, if the stream is writing, then it's your character. So we own this player. So then what you do here is I am sending my transform position, and then I'm sending my transform rotation, and then I'm getting my character controller, and I'm sending my state, the current state that it's in, whether he's running or shooting or whatever. And then here I also send my name, my network name, and then I send if I'm shooting. Sorry, I said that in the state. It's actually different. I actually have a shooting. The character state here is for animation. So I send if I'm shooting. If I am, I send a 1. If I'm not, I send a 0. And then I go ahead and send the fire point is the location on my character of where my projectile is originating and the current rotation of it. Now, if it's not writing, then that means it's a network character. So I'm receiving data, so I need to update my local machine with that character's positions. So I take this and I receive it. You receive it in the same order that you send it. So since I sent my transform position and rotation was the first two, that's the first two that are going to come in. So this is the correct player position and the correct player rotation. And I just keep doing the same thing. I go through and go down and basically assign all the stuff that was sent to where it needs to go. And then if I'm shooting, what will happen is you set these RPC events that will be fired on the photon view of the player that is requested in the call, right? So this here photon view player is always, it says here, it's always the local player. So I call this remote player shoot, because instead of instantiating the projectiles across the network, I just instantiate the projectile location and rotation, and then I instantiate it locally to prevent, because it's just too much traffic, and then there's a lot of issues. I had a lot of issues slow down, and it's just not very efficient. So then that calls that function, and I have an actual script attached to everybody called RPC functions. Now, after going through all this, there's like 1,000 ways better to do this. I would definitely do it differently, because I have too many different scripts scattered throughout that doesn't really make any sense, not very logical. So, but the good thing about this exercise is that it was at least able to identify what needs to be planned properly when using the Photon networking, because it was kind of confusing on who's a network player, who's not a network player. Okay, so this is my RPC functions script that's attached to every player, and these I can call from any view. And if let's say, for example, you send a RPC function and you say, I want to call game over, which I'll show later. I do call this, of course, and you pick which players are the target that's to receive this call. So most of the time, all my stuff is all players. So let me zoom in here. Okay. So this is the remote player shoot. It takes a vector 3 for the position and a rotation. And then what happens here, dang it. Alright, so I grab the character controller for whatever this view is on, and then I check to see if the animation is playing for the shoot animation, or that it's not playing, and if an animation is playing. If so, then I stop the current animation and I go ahead and set the speed for the shoot animation, and I play that one. Now, one thing that usually you do is you use crossfade instead of play, because it'll fade the animations in, try to blend them together. But for some reason, when I added on certain animations, it doesn't crossfade correctly. You don't even see it play. So I didn't have time to figure that out. But then I check and see, make sure that the cooldown, which is the shoot cooldown, is less than or equal to 0, and that the player that is receiving this call is local. And then I'll instantiate the projectile from the position and rotation on the local machine. And then I also have some on GUI functions here that checks, like if the game state is game over, then it'll display the game over screen on all clients. And in the game over window function, let's see, there we go. The game over window function, it grabs each player, it grabs their player script and checks their health. And if their health is greater than 0, then of course you won, and if it's not, then you lose. And then it displays the window. And if the button says quit, you click on the button and it destroys the game object and disconnects and takes you back to the main menu. Ideally, though, I was working on spawning. You would like to respawn, set a number of rounds or whatever, but ran out of time. So now look at this here. Okay, so I have a couple more interesting RPC functions here. One is to play shoot effect. So anytime the user fires, it plays on a local. It sends this out, and then this sound effect is played on every local machine. And of course, depending on the distance and all that stuff, it fades it automatically. It's actually pretty cool. And then I have one for take damage as well. So this is called whenever someone is actually hit by a projectile, and it checks to make sure, hey, if this photon view is not mine, then just get out of here, because all I care about is the local system. And then it grabs the character controller, the player script, checks if the character is dead. If he's not, then it decrements his health, and then if he is dead after that, then it sets him as dead. So zoom out of that. What else we got here? That's pretty much it for the networking side. So we'll just start going through now. Some of these scripts I actually modified from Java, the Java scripts that were in there. And one of them is this bullet controller here. This was taken from a sci-fi particle shooting effects script. So I went ahead and converted it over to C#. And basically, this just controls a projectile and creates particle effects for it. So that purple laser that you see. So here it creates a muzzle flash. It adds adds physics, adds force to the projectile, and then if the projectile hits something, then it instantiates an explosion particle effect. And then this detach on death. This is something that basically I'll show you that there's a sparks effect that's attached, and by doing it this way, what happens is the particle system gets detached by setting the parent to null. So that way, when the projectile is destroyed, the sparks still get time to finish running before they are destroyed separately. That's all there is to that one. Not much to it. How come I can't zoom out? How did I do that? There we go. Whoa. Okay. Alright. Now, see this clear. Alright. Destroy this timed. This script is basically attached to a projectile also, just in case it continues to fly and doesn't actually hit anything. After 5 seconds, it will destroy the projectile. So you see here, it starts the code routine, and then I have the enumerator here. It yields, waits for 5 seconds or whatever time you have in there, and then after that, as long as the object is not null, it'll destroy it. It's a good way to keep projectiles from flying around your screen, going on forever. Okay, so game logic was actually there's a lot of scripts that like game logic and game state that actually aren't being utilized to their fullest or how they should be. I didn't start this until after, but it's one of the scripts I have, so I guess I'll show it. This isn't actually used at all. I had made a scene view, photon view, just to see, so I can call RPC functions, but I ended up never using it. So even though it has the take damage stuff here, I don't actually call it from there. I don't use it at all. Okay, game state. This was a work in progress. I never got around to finishing this either. You see, I don't even have I have states that really aren't being used. Game over is all I really use, so I still got a lot of states to add. But I started to implement the round system, so that way I can increment the rounds and determine if the game's over that way for respawn. And then, let's see, this is my character controller. Now this is a modification of the Unity one that's built in. So I'm just going to show the changes that I made and what I'm actually using. Let me clean this up a little bit so we can see it better. Okay. Alright. Okay. Alright, so let me zoom in. Alright, so I got my global variables here. And this is mine. It's Firepoint. This is actually an empty game object that is attached to the weapon, the tip of the weapon. And this is a raycaster. Well, I call it a raycaster. I was using it originally for the mobile. I was trying to set it up to where you didn't have to shoot with a button, that it would shoot out a raycast. If it hit the player, it would start shooting. It worked, but it wasn't so great. It wasn't very, it didn't have a good feel to it, so I'm actually not using it. This default projectile holds the particle effect for the laser, and these are animation clips for idle, walk, run, shoot, jump, and dead. Not using jump at all. And then I have some variables to check if the character's dead. I have some speed set for the animations, and audio clip, which is actually not being used, I don't think, here. No, it's not being used here. I'm using it in the RPC, but I started locally to see how to get it to work. But this cooldown here is for the weapon cooldown to shoot. This enum is for character state, and here's the character state as well, the actual variable. These are some stuff I have that are built in. I didn't mess with these. This is like the walk speed, the trot speed. So over time, you notice the character starts to walk, and then after a while, he starts to run. That's built in. This is from the third-person controller script that's provided by Unity if you import the standard assets. Okay, this isn't used. This is all stuff that is from Unity. Okay, and then I added this is controllable. Shooting. Can jump was already there. I just didn't remove it. So let me minimize that. Okay, and these are some private variables here. This is the actual animation controller. And then this is a boolean I have set up to make sure that the dead animation only plays once, because originally you would kill the guy and he would just keep dying over and over again. It was actually kind of funny. And these are all from Unity. I didn't mess with any of those. Let's see. Well, that's pretty much all I added to that. And then I didn't mess with the awake function. Now this check shoot function, this was the one that I had that would do the raycast, and it's very simple. I even had it debug draw the ray as well, so I could see it in the scene view. But basically, I create a new ray, and the ray is from my raycaster object position, facing forward is where it's shooting the ray from. And it's this right here. By doing the raycaster transform forward, it's forward relative to this object. So it's always, no matter where you turn the character, it's always going to be facing forward. And then this raycast hit, this holds information anytime you shoot out a ray. So you use the physics raycast. I pass in the ray, and then I have an out variable here for that hit info. And this is the range. I'm shooting at 500. I don't know how many units, how far that is actually in the game, but it worked out pretty far enough. So then if there was actually, it would check to see if the hit info, if the collider was the name of troop, because that's what the player character name is, troop. So if it did, if it was another character, then it would check to see if the current character state is idle or if it's not moving, because then it didn't have to play an animation. It would actually shoot. But I have it commented out because I'm not actually using this at all. But it did work. It worked pretty well, but it just didn't feel right. So this is the actual shoot function here. Whenever the spacebar is pressed, I grab the character controller, and then I check if it's not moving. If he's not moving, then I go ahead and call the. Here I'm getting the photon view of the object, and I'm calling the RPC function. So I do play shoot effect, so it plays the sound effects, and the target is set. Oh, there we go. Sends it to everybody on the network. And then it instantiates. I'm sorry, I'm really having a hard time getting used to this. It instantiates the default projectile. And then if the character is running, it'll go ahead and check if the running animation is playing, or if the shoot animation is playing. If it's not, it'll go ahead and play it. And then instantiate the projectile. So that's all there is to the shoot function. It's pretty straightforward. This updates smooth movement direction. Now, a lot of this is default from Unity. I'm pressing the wrong button. Okay. So this is from Unity. It just holds the. Oh gosh. What is wrong with me? Okay. Try this again. Nope. That's good. Alright. Okay, so this is the camera transform. That's built in, is grounded, just determines if the character is on the ground. This is all built-in stuff. Now I did add this here. It's basically checking if this is controllable and he's not dead. That means if it's controllable, that means it's the local player, because only the local player sets that variable in the beginning, like we showed, to true. So if it is the local player, then go ahead and get the access information, from the V and H, which happens to be the keyboard. When you do the get access raw and get access and you put vertical or horizontal, it's whatever the default inputs are, and there's one for joysticks and keyboards automatically called vertical and horizontal. Now if you didn't have this in here, you would control both players. They would fight over that. So this is all built-in Unity stuff. I didn't change any of that. Like I said, these scripts are provided by the standard assets. All that's the same. Alright, so that's it there. I do believe they might be Java though, because I know I had to convert these to C#. I prefer to work in C#. Okay, apply jumping I didn't do that. It's automatically, I don't do any of that. Now the update function. Did make some changes here. Biggest change I made is to check and make sure that the character is not dead, because he would die and you could still shoot and he would try to run and all this stuff, so it's kind of funny. But anyway, if he's not dead, then it'll go ahead and check, okay, are you controlling it? And I'm not using jump, but that's there. I didn't change. I just added the are you controlling, just in case I was gonna try to add jump later. And then it does the update smooth movement direction function, which we'll look at. And then I check to see if shoot cooldown is greater than 0. If it is, then the character is not shooting. He can't be. And to go ahead and decrement the cooldown. And see, these are all normal built-in Unity stuff. I added the is controllable to make sure that it only moves the local character, and because the network character is controlled in the other serialization script that we saw earlier. Now here I added this to check to see if the keyboard is up. As soon as they press it down, if it comes back up, then the character is not shooting. And then when you do the key down, then the character would shoot. Makes sure that the cooldown is less than or equal to 0, and then that is controlled locally, and then it sets shooting to true, and then it calls a shoot function, and then it sets the cooldown to 0.25. And then if it's not controllable, it's a network character, it sets it to true. And that might be, that's interesting. I'm gonna have to look at that. That might actually be an issue. That might be the cause of my double no, that's right. Okay, sorry, get sidetracked. Okay, so this is the animation stuff. All this is default. The only thing I added is here, this is controllable to set the idle state of the network character, because if not, the network character is always running. So because by default this script is set up to for the local player, and he grabs the idle state later. However, the network player wouldn't, so this sets idle right here, because by default this isn't in there. It's just it sets the animation. And then all this is default, with the exception of I just copied and pasted to add the dead animation here if the character state is dead, and that's it. And this is the only thing I added here was his controllable. and then I added to call the dead function if at the beginning of the update the character is dead. So we'll look at the. That's not me. I didn't do any of that. Is moving. Oh, take damage. Where is the? There it is. I must have missed that one. No, I already showed that one. Okay, sorry. All right, and then the only other one I have is the. That's not even used. The dead. Okay, so with dead, it just sets dead to true, sets a character state to dead. If the death animation hasn't played yet, then go ahead and play it, and then set that it played already, and then call the RPC function on all clients. Game over. Okay, so that's it for that one. That was the biggest. I think that's the biggest one. Let's see. So this one's not being used. I was trying to use Mechanum, or however you say it, for the animation, but it didn't. It was proved to be a little difficult. Some of it was kind of cool. I got some of it to work, but it wasn't working as well as I would have liked. But I would love to revisit and use that instead of the legacy animation system. It's a little bit more powerful. Okay, so network character we looked at, networking we looked at, player we looked at. Did we look at that? Let me see. Okay, so okay, so the player script holds some information for the player, like his health, his name. This isn't actually being used at the moment. Okay, so whenever a collision is detected, it checks to see if the name of the collision has bullet in it, and if this is not the local player, then it just exits. It doesn't do anything. But if it is, it grabs the photon view and then calls the take damage to everybody, so everybody can take care of it. But in the take damage function, it also checked if you're local to or whatever. So that way, I mean, everyone doesn't get damaged. That's the confusing part for me with Photon, is understanding how this works, because kind of doesn't make sense. But I guess it does. I'm still trying to get used to it. But yeah, so that's all that's in there. That, and then I have an on GUI function here for each player. It checks and makes sure that if this is not my photon view, then to leave, to exit. Because if not, then it's going to draw the health for every character on your screen. And it looks kind of crazy. So here it draws the health, it grabs the health variable and puts it in the top right corner. All right. Went over that. This is not being used. This is spawn point. Okay, so this is, I got this from, I copied this from the same idea from someone else's project online. They had the respawning working really well, so it's really cool. But mine's not working so well. So anyway, what happens here on start? It grabs an instance, or it takes the instance, because you take the script and you attach it to a game object. Okay, and wherever that an empty game object, and then wherever that object is, it takes and registers it as a spawn point that you saw in my networking function to begin with. And then it has one function here, is clear. So the way, well, actually it has a couple. Sorry. So the way the is clear function works is it uses a physics overlapping sphere to the based from the position of the spawn point, right? With a certain radius, which happens to be 10. So any collider that is in that radius of the sphere gets put into a collection. So I iterate through the collection, and I check if the collider has a tag of player, then return false. So basically it says I am not clear because there's somebody there. And then if there's not anybody there, then it will return true. And then this onDraw gizmos is actually for the Unity interface. So what it will do here is it basically draws a blue sphere wherever this script is attached. So if you look, if I go to the editor here, you see you can see these blue spheres. These are actually spawn points, and all they are empty game objects that I called spawn point that have the spawn point script attached to it, and then you can set the radius to whatever. So okay, so that's it from those scripts. Now I have a mobile folder here that I set up, and this is I was starting to look at the Smart Fox networking. I won't show that. That's actually pretty cool too. I really like that one. But anyway, this mobile control, I took one of the from down here, the standard assets mobile. I just took one of those controls and converted it to C#. So it's all default. You can actually, I probably can't see it. So let me scroll down. So from the standard assets mobile control setups, you can grab what it is. I grabbed one of these and looked at it and seen what scripts were attached, and then I grabbed the right script and converted it to C#. So that's what that's about. Main menu. Okay, so on the main menu, there's an animation. Let me go to the main menu. See scenes, main menu. Okay, save. It's fine. Hope I didn't change anything. All right, so this is the main menu. Let me go ahead and play it, and you'll see that there's an animation. The camera animates down, pans down to this area here. So the way I did that was very simple. I have two empty game objects that represent the start position and the final position of where I want the camera to go. Let me see. So I have the start position, which you can see up there, and if I change it, it's on the top, and then the final position of the camera object. And you can't really see that it's offset, but anyway, so that's what that does. And then I have one light in there, and fonts, I keep them together. These are the fonts for deathmatch and for the word. Let's see if I can move this so you can see it. Yeah. So those are the fonts for my menu there. So I have deathmatch, I have main menu, which I never finished, and then tap to start. Okay, then of course there's the main camera. That's the one that's built in by default, and then meshes are basically is the level. You know, all the meshes that are in the scene. Scripts, it's an empty game object, and it has a locations function script attached to it. And then I downloaded a copyright, I mean it's copyrighted or whatever it is, but it's the Army theme song, so I went ahead and added that in, and that's what plays as the main menu. I have it set to loop and play on awake. So let's take a look at this location functions here. This is the part that I did to meet the requirements for the hardware part of the assignment. Now it looks like a lot, because what I did is I went to the wiki, the Unity wiki, and I found this simple JSON or JSON, or however you want to pronounce it, but basically it goes out, it'll parse JSON files. So I thought, because when you get the location information with the built-in Unity functions, it will bring back a latitude and longitude, or longitude and latitude, and that's not very exciting, right? I mean, at least not to me, because there's no way of knowing. I mean, I could have put whatever longitude and latitude on the screen and been like, hey, this is where you're at, and actually you really have no idea. So I looked up on Google, and Google has some APIs that you can call, some web services, and one of them is to actually send them a longitude and latitude and get back the actual address, and it'll be like a formatted address or however you want. So I was like, awesome. So what I did is Unity has a built-in World Wide Web class that can post and get and do stuff on the web. You pass it a URL, it'll do whatever and bring it back as text. So I set up some strings here, and this I got from the actual, basically going to the Google API site and trying to, the top one here, the one that's commented out, this is actually the original one from Google. So I took that and broke it out into separate strings so I can build my own string. And then I set the local address to nothing. So this stuff here is to enable the GPS. So it starts with the numerator and it checks, okay, this is checking if it's enabled. And what this means is if location services is enabled on the device. If not, then it just doesn't even try. But if it is, it goes through and initializes. It waits and does its stuff, and depending on what happens, it'll time out, or if it fails, it'll say that it wasn't able to check your location. But if it succeeds, here is where I have the complete URL, which is a variable I made that takes that initial URL. It takes the last data latitude from the device, puts a comma, and then adds a longitude, and then the second part of the string. So this is basically building the Google request string. And then I start my coroutine to go ahead and try to get the address. So down here, this right here, this get the address, it takes that URL and tries to get it. Okay, tries to pull the data back. And then in my update function, it checks to see if it's done. If it is, then if the local address is blank, like I haven't adjusted it yet, then what we'll do is I'll instantiate this. I'll use the JSON.parse and basically take the text that's returned, because Google's web API returns a JSON file, and I take that and parse it and assign it to this variable here, to R. And then I take location, my location info equals, and the way it does it, it sets it out to each element in the file as an array. So it's kind of cool, like it's very simple actually. So I have the results, and then the first part of the results array, the first element that's called formatted address, I take that value. So on the mobile device, if you run the main menu, in the top left corner, you will see you'll see the messages for the GPS. It'll tell you if it's on, if it's off, and then it'll tell you what your location is. And it's actually surprisingly accurate. And that's all there is to it for the main menu scripts as far as location, grabbing the GPS location from the device. And then I have a camera animation script, and this is what animates the camera from basically from those two locations I have, start location, the end location that I showed you, and how fast. And when we look here, during a fixed update, it takes and it lerps the camera position and the rotation between the start and end position. That's all there is to it. I mean, it's very simple, straightforward script. And I believe that's it as far as scripts goes. Now I can go through, let's see, I got a couple more things I guess I can explain. That's probably pretty interesting. The graphics are pretty good, I think. And the way I achieved that was using light maps. I went ahead and put that. I was thinking about the mobile side anyway, and real-time lights just don't work. Plus, you have to have the Pro version. I do have the Pro version, but not the Pro version for mobile. So anyway, I went ahead and it's very simple. You have your light in the scene, and then you just go to your window. Where's my light mapping? And so this is the light map menu. And you just go through and select whatever, make your options, and then you can check the bake stuff. It's pretty straightforward. I'm no expert at it. I just messed around until I got the look I was looking for. Ambient inclusion and the color I grabbed. I used the picker and I grabbed from the background that I had set up, the skybox. And then you bake it, and then it'll sit there and bake, and then once it's done, it takes the files and it'll generate these light map files for you. But it'll do it. So these are all the light map files that it generated. Another thing I'm using in this, and it's just because I wanted to learn how to use it. I've had the pro version, but I haven't had a chance to do a lot of things. So, was light probes. So, one of the things that's pretty cool is you have your baked scene and all that light. With the light probes, you have all that information calculated. So, if you have any objects that uses light probes, like if you look in any object you have that has a, I believe it's anything that has a mesh renderer. Not 100% on that. Let me find it. Character controller. Oh, maybe, yep, I guess it's only mesh renderers. Well, you can't see it on this one because the mesh renderer is hidden. There is an option for use light probes. Let's see if I can find one. That's actual raw FBX. Prefabs. Okay. So here, anything that has a mesh render, you have the receive shadows, cast shadows. There's an option to check use light probes, which I have. Maybe I should zoom in. It's right there. So I have that selected on my guy, and what that does is when he runs around the screen, I don't know if you'll be able to see it very well. Let me see. Okay. Let me find a spot. So what's supposed to happen is when it's sampling the light from all over and applying it to the mesh, right? At least it's supposed to. I don't know if I have it set up correctly, but if I move him to a darker area, you see he darkened up in the back here, and then he lit up that way, and that doesn't cost anything. I think even if right now I have the light on for dynamic shadows, but I think if I do it without the light, it should still work. Grab that. Okay, so you see he's dark in this shadow. It's a very minimal change. Huh, but it works. So see, and there's no lights in the scene at all right now, and it's just using the light probes, which is awesome. I think it's great, and it was very easy. So what I did is I created an empty game object called light probes, and I attached a light probe object to it. And then all you do is click on add probe, and then you drag them out to where you want. Like I put one there. Hold on, let me zoom out. Zoom in this way. So these yellow dots. So it creates one, and then it has really intuitive controls to where you can duplicate the selected and then move it over, and you keep doing that until you get a row. And then after at least you can do either way, however you want. But I started in the left corner, went all the way to the right corner, and then I duplicated the entire row and then went up. And once you finished the entire level, then I selected all of them and then went vertical, because it has to be a volume. But anyway, so that's what I decided to implement as well as the light probe, so it looks pretty good. And that's pretty much it. So that's my project. I hope you liked it. I hope you enjoyed it. And I will also include a video of the project running on Android where you can see where it's grabbing the GPS location information. One thing I would do, if you could, it would be really cool, is just go ahead and change the project build settings to Android and just build the main menu. And you could build the main menu and the Android no. Let me see. If you build the main menu and the Android no multiplayer, and it'll work. You could also see that on the Android I have joystick controls, but I'll show that in the video. I plan to do another video with a little bit more detail on the Photon. However, I followed the tutorials on Exit Games for the Marco Polo tutorial. I'll put that link in the video. It's a very good tutorial that gets you started, explains a lot of things, and then just trial and error from there. Alright, well that's my project.
Yeah.